This is Dr. Carroll with a video about function templates. Function templates allow us to reuse code, and when you think code, you can think an algorithm for many different data types. And code reuse is a very important principle. Let's see an example. Here we have an array, an integer array that we've hard-coded here. We're going to do a little size of math here to say, well, how many bytes are in the array? How many bytes does the first one take? We'll divide it, and since it's a homogeneous array, it'll tell us how many elements are in the array. Then we call print array, defined here, with the array, so it'll get the base address of the array and the number of the count of the array. Okay, we pass it here. We do a simple for loop, print out the elements, add a new line. We're done. Let's see it. Runs 3, 7, 42. Sorry, that's a little small, but it works. Great. Okay, now what if we wanted to do a character array? Instead, I can type. So here's a character array. Oh, shoot, now we've got to change that to char array. Oh, hey, we're good. We're done. Okay, that's it. So let's see it again. Everything else stays the same. Oh, great. A, B, C, D, E, F. Okay, now your boss is so impressed with your print array for ints, arrays, and now char arrays. He wants one for Boolean. He wants one for a short. He wants one for a long, a float, a double. And how about a DNA object as well? He wants one for everything. Well, there's a solution for that. We can make print array templated. The way we do that is we use the keyword template, type name, and then we need to specify the template type name variable. So we'll say, template type. We'll just leave it at that. Template type is, we choose this. You'll notice the other ones are blue. We get to choose them, and then we just say, hey, this is of type template. And do we need to change anything else? No, that'll work great. Okay, let's see it in action. Hey, sweet, it printed. Okay, now let's really see the power of it by putting this back to our 3, 7, 42 example. And let's do 99 just so it's a little bit different. Okay, now we need to build this. Building, sweet, it works great. So that could work for anything. And notice the only thing we had to change in the function was the type here. This one stays the same. Oh, you can't see that, sorry. It had int count. The count stays the same, but everything else is fine. Okay, so that'll work. And to call it, oh, one more thing. To call it, when we're calling a templated function, we might need to pass in the type just so the compiler is very happy and it knows, oh, hey, this type here is going to be fed into here. And so if there are certain situations where the compiler can get confused, and so we just tell it, hey, this is exactly what the type is that for the type name. Okay, but notice it worked without it, and generally it'll work, but there's cases when it won't. Okay, there is a gotcha though, and the gotcha is that the insertion operator needs to be overloaded. So that's the only real restriction. Looking back here, that's the only real restriction for this method, is that whatever data type is here, or the template type, needs to have overloaded that operator. Okay, so let's talk about the syntax for function function templates. So we have to have the keyword template, we have the less than sign, then we have type name, or you can actually use class there, and then we have a template type, variable name, whatever we want there. And then we specify the return type for the function. We have the function name, and then we have the parameter list. And then we write the function as usual, and we return something. That's the general syntax that you always have to follow. Template's a keyword, type name's a keyword, class is a keyword. I like I like temp name because we already have class means something to us, and that's the general syntax. Let's see another example. Let's do a getMax function. You've probably written one of these before. Let's write it initially for an int, 2 ints actually, and then we need to return an int, and we could just have it return a is greater than b. We can use the conditional operator. Make sure my parentheses all match up, and there's our getMax. So if you're not familiar with the conditional operator, this says, hey, evaluate this. If it's true, do this. If it's false, do this. So we're going to return A if A is greater than B. Otherwise, we're going to return B. Pretty simple. Now let's template it. We need the template keyword. We need type name. A very common template type variable is T. Very common. We can put a T there and a T there, and hey, we're done. Is there any gotchas? There is a gotcha. Gotcha here is that the greater than operator needs to be overloaded. And then everything will work. So we could use this for integers now. We could use it for chars. We could use it for string objects. String objects have a greater than operator overloaded. We can use it for a host of different types, but we only had to write one templated function. And that's a cool concept. Again, we would call it by calling getMax. You have int x, y, for example. We'd initialize them, and then we could pass along int x, y. Now, remember, sometimes the compiler will get confused, not always necessary, but that's how we'd make the call, okay? A key point here is that in these examples, printArray and getMax are not functions. You're saying they're not functions? Sure look like it, but are patterns of functions. They're templates of functions. The real functions here are array, int, a printArray, templated type for int, and printArray, templated for char. Those are the real functions. And of course then for getMax, the int and whatever else. Those are the real functions there. So you need to keep that in mind, that templated functions are not functions. It's only when they have a type that they become a function. Okay? So now let's see an example for multiple data types. What happens if you have more than one? Working on my... Okay, multiple data types. So we still provide the same template keyword. We provide type name just as we did before, but now we have a one temp name, and you could name that T1. That's very common. And then you have it, you repeat type name, and then you do T2 or temp type name as illustrated here. So this function print values, it'll take one templated type, and we're calling that parameter A, and it can take another templated type and calling it B. And these will work if the insertion operator is overloaded for temp type 1 and temp type 2. The only gotchas there. Okay? So for example, we could have J equals 9, and we could have a char equals H, and then we could have a print values, And here, if we were going to specify the type, we'd need to do int comma char, and then we could pass in j and k. The compiler's smart enough in this case, we're not doing anything too tricky, that we can just call it without those because it can figure it out. All right, that's it for today.